Hey everyone. I got a couple of emails from various students who are having trouble with this kind of problem on the homework. I know this is one of the problems, and this is the one specifically that some students are having issues with. Um, so I just figured I'd go over it, help you guys out a little bit because it's spring break and thinking a lot is not what we want to do. Um, okay, so let's go ahead and do this problem. I'm not using these numbers at all. I'm using different numbers just because just in case this is one of the number sets that you're given, I want you to do it on your own. Um, so my numbers are this. So I kind of made my own little thing of it. But yeah, let's go ahead and try this. Um, Same exact concept, just different numbers, so relax. I'm using the exact same uh, chemical reaction. Nothing else is different except these two numbers. Simple as that. So if you haven't figured out already, biggest thing that I want you guys to know is that this, oops, let me try a different color. This compound is for this column, right? Then this compound is for this column. Simple as that. This column is for this column, and this column is for, or that compound is for that column. Simple as that. So basically, and it kind of makes sense too, right? Because initially mixed you have 0, and these are products. Products, you don't have anything mixed just yet because you're making those. You're not mixing them. So with that being said, let's go ahead and start this problem. So the numbers I have, let's bring back the numbers. There we go. So try to write these down somewhere, take a picture or whatever. I'm going to actually change to a gray screen now, and we're going to go ahead and start this. So the first thing we're going to do is we are going to find out how much we've reacted. That's the most important thing to start with, because you need to know what's limiting and what's not limiting. So how do you know it's limiting? Well, let's just start in terms of the numbers that you're given, the gram values. So you know that the gram values are 0.257 and 1.450 for ethane and oxygen, respectively. So let's start with ethane first, or ethane, whatever you want to call it. So we have 0.257 grams of ethane, right? C2H6. Right, and that's over 1. And then we are combining that, or so we're going to react that. So we have it in grams. We should convert it to moles, right? That's how you find limiting reactants. So let's convert it to moles, and you know that 1 mole of C2H6 results in the molar mass, right? That's the molar mass, grams per mole. Molar mass of ethane is 30.07, I believe. Yeah. Great. So we have that. We actually cancel out grams of ethane, right? Actually, let me use different colors so you can see the cancelization. You cancel out grams of ethane. Oops. Grams of ethane, right? At that point, we're not done yet because now we have moles of ethane, but we actually need to find out which one's limiting. So the best way to do that is to actually react completely to one of the two products. And I'm just going to go with CO2. So let's do that. Well, at that point, with this in mind, I'm going to erase part of this right here. We know that for every 2 moles of ethane, right, for every 2 moles of ethane, C2H6, we result in 4 moles of CO2. Oops. Moles of CO2. How do I know this? Well, let's go back real quick. You see here that I have the molar ratios 2, 4. That shows that for every 2 moles of this, you have 4 moles of this, either required or as a result of. So basically, the idea behind this is the idea here is if you're switching from moles to grams, you just do another. Sorry, if you just do some kind of conversion factor. But when you're going from a different compound, like here we're going from moles of CO2. We're going from CO2 to or we're going from ethane to CO2, that means we have to, when we're jumping ship in terms of actual compounds, we need to use something that relates those two compounds together. In this case, that'd be the molar ratios, the coefficients. So that should kind of tell you that balancing your equations is super important, because if you do the balancing wrong, this part will result in incorrect, right? Just because you're relying on those numbers. So just thought I'd throw that out there. But great, okay, so now we canceled out moles of ethane. We cancel that out. So now we have moles of CO2 produced. That's what this means. We've reacted 0.257 grams of ethane, and now we're calculating how much CO2 is being created. So in this case, we're not done yet, because now we have moles of CO2. We should go to grams, just because grams is the value that we all measure in, right? That's what humans measure in, or human scientists at least. So let's go from moles to grams. So moles, now we're in CO2. So 1 mole of CO2 equals 44.01 grams of CO2, right? So 44.01 grams of CO2. That's just the molar mass, right? Moles per gram, grams per mole. Great, so now we've canceled out our moles of CO2. Cancel that out, so we're left with grams of CO2. That's what we want. So you go and pop this in your calculator real quick. That should be the quickest part of this, is calculation, and you should get a number of, oops, trying to zoom in on my iPad. This is awkward. 0.75252 grams of CO2. Wonderful. That means nothing to us just yet. That shows that if we react all of the ethane, we get that much CO2, but we don't have anything to compare it to just yet. So we're not entirely done. Now we have to assume, okay, so this first part right here, this whole thing, we assumed that ethane was our limiting reactant. Now we have to assume, just to compare it to see which one is actually limiting, let's assume that oxygen gas is limiting. So for oxygen, remember that we used 1.450 grams of oxygen. So let's go ahead and use that. So let's do another one of these. So basically you're going to do 1.450 of oxygen gas, grams of O2 divided by 1. Just have it over 1, whatever. Multiply that, same thing as we did above. We're going to convert to moles, go from moles of a product, a reactant, to moles of a product, go from reactant to product. We're jumping ship from one reactant to another compound, which in this case is a product, and then go back to grams from that mole value. So really quick, really easy. This should become second nature to you after a lot of practice. So from here, we have oxygen gas. 1 mole of oxygen gas equals, it's O2, right? It's not just oxygen, it's O2, so keep in mind, you have to do 16 times 2, so that's 32.00 grams of oxygen gas, right? So then oxygen, so the grams of oxygen cancel out. Great, so at that point we're left with, we have moles of oxygen. Now let's go ahead and use our chemical formula, the thing on the other page, to determine how many moles of oxygen go into moles of CO2. So let's go ahead and look back real quick. We know that, okay, 7 moles of oxygen gas, 7, coefficient of 7, 7 moles of oxygen gas is what's required to make the 4 moles of CO2 gas. So let's go back. Real quick, also, if you use CO2 up here, you need to use CO2 down here as well. You need to keep consistent with the product, or else you can get a very different number and you could get misrepresentation. So, okay, great. Let's go ahead and do this real quick. Sorry if I say real quick, I'm not trying to insult you, that's just a habit. So, 4 moles, for every 7 moles of oxygen gas, we're resulted with 4 moles of CO2. At that point, we have canceled out moles of oxygen gas. So at that point, it's just all about converting from CO2 moles to grams of CO2. We've done that before, so we know that 1 mole 1 mole of CO2, is the molar mass of CO2, which is 44.01 grams of CO2. At that point, you calculate the whole thing out, and you should get a value of 1.13. I checked all my math, so I know I'm right. 955 grams of CO2. There we go. Now we have two different reactants that we've assumed are limiting. Now, which one is limiting? Well, it's the one that produced the lower amount. That's because, well, this one, if we're making a lot of CO2, we have to keep in mind that we're running out of the other one, right? So basically, that means that the lowest amount created means that that compound, that reactant, is our limiting reactant. So we can assume at this point that ethane, C2H6, ethane is our limiting reactant. So that's all we've done so far. We've identified that ethane is our limiting reactant. If you know how to do that, great. Now we're going to move on to the more fun stuff. So real quick, do realize we just figured out a couple things. So this wasn't all useless. We got some numbers out of this. Currently, we know that ethane is our limiting reactant, and because we know that that's our limiting reactant, we just calculated how much CO2 is being made. So we can go back here and we can basically fill out, which one? Let's see. So we know that ethane, if it's a limiting reactant, we know that all of it's going to be reacted, right? Because limiting, all of it runs out. So we can write 0.257 grams. We know that. We also know that we just calculated, hold on. Yeah, sorry, I blanked out for a second. Okay, right, so we know that we ran out of our limiting reactant, which we just figured out was ethane, and we also did calculate how much CO2 is produced, which is that other value we got of 0.752 grams. So basically, we're almost done. Now we've got to figure out, and also we know one more thing. If ethane is our limiting and we've used all of it, at the end, we have none left, right? So this is just 0.00 grams. So great, we got half of it done already. Let's do the other half. So, okay, we know that ethane is our limiting reactant, so at that point we can actually figure out what our excess is, what we have left over in terms of reactants. So, let's go back to a... Oops, don't know what this is doing here. Oh. I do know what's going on. Okay, great. So I erased some stuff. Sorry about that. Okay, so at this point, we know how much ethane we're using, right? It's 0.257 grams. Oops, 0.257 grams of ethane, C2H6. So at this point, we're going to go ahead and figure out how much of the other reactant, oxygen, did we use. Because it's not the same amount, right? It's the same in terms of moles, but not in terms of grams. So we have to figure that out. So, okay, great. We go from grams to moles, just like we did before. 1 mole of C2H6 is equivalent of 0.07 grams of C2H6. Wonderful. So now we have moles of C2H6, and before, just like what we were doing, we were canceling everything out. We're canceling out units. That's important. If you don't cancel out units, you're basically screwed. I guarantee you won't be able to do this. So we're jumping from moles of C2H6 ethane to moles of oxygen, right? We want to find out about oxygen now. Same thing, even though it's still a reactant, you're jumping ship from one compound to another. So you have to figure out what do the compounds have in common. Well, the molar ratios, right? The molar ratios associate with each other. So we know from the reaction, I'll bring back up the reaction, every 2 moles of ethane, you need 7 moles of oxygen gas, O2, right? 7 moles of O2. That is not the same as 14 moles of oxygen, just O. Do not do that. just use 7 moles of O2. People make mistakes the other way, so I recommend you don't do that at all. So, okay, we know that for every 2 moles of C2H6, you need 7 moles of oxygen gas, of O2. So we're not done yet because we're still in moles. Now we have to go back to grams. So you have moles of oxygen gas, right? You're canceled out moles of ethane. Moles of ethane. So let's just go from moles to grams now. So that's 1 mole of O2 equals 32.00 grams of O2. And then you calculate all this out, right? Because you've now gone from moles. Now we're at grams. This is grams of oxygen that we've been used, right? It's not what's left over. It's how much that's been reacted in the system. So when you do this, you get a number of 0.957 grams of O2 used. So well, great. We don't really care about what was used. I mean, we do. So so now you know how much was used. You can go back here and you can fill out how much is reacted, right? That would be the 0.957. Now what's left, however, requires one additional step. And that's simply that you know initially that, and this it's given to you in the problem, initially you were given 1.450 grams of O2, right? Of O2, initial. And we've reacted, I just did the math, we reacted 0.957 grams of it. So just subtract it. And you get 0.493. Yeah, 493 grams. And that is how much is in excess. That's how much is left over. So in case you have other problems that ask for excess, this basically is just, you're just finding how much of the non-limiting reactant you've used. Now with that, you're given an initial, obviously, so you do the initial minus how much you've used to get your excess. If you don't do that, you haven't done the math right? It just makes sense. So hopefully that made more sense. So that's excess. You put this value in for this area. So now we only have a couple more boxes. We have these 2 boxes. Actually, we already finished one of these, so we're left with the other one. And I'll do both again, just so that you guys are aware. But now we're looking for how much product are we making. And that's pretty simple because we have our limiting. We know ethanes are limiting. So let's just do it again. I'm going to do this really quickly because I don't want to keep up too much of your time now. So we have 0.257 grams of C2H6. Always start with C2H6 because it's limiting. Put that over 1 just because that's my habit. Convert from grams to moles because moles is the thing that we work with. So 1 mole of C2H6 is equivalent to molar mass of 30.07 grams of C2H6. From there, we're jumping ship from C2H6 to our product, which the first product is CO2. So we're jumping ship. We use, always, when you jump ship, you use molar ratios. You use the coefficients. And those are given in the reaction. I've gone back to the reaction multiple times. You guys should know that by now. And we know that for every 2 moles of C2H6, we have, what, 4 moles? 4 moles of CO2. So great, now we've jumped from moles of C2H6 to moles of CO2, a product. So now we're on the product side, and now we have to go from moles of product, unless it asks for moles. In this case, the question asks for grams of product. You have to go from moles to grams, which is just utilizing molar mass. Molar mass of CO2 is 44.01 grams per mole, so 1 mole of CO2 equals 44.01 grams of CO2. If you do the calculations, you should result in a value of 0.752 grams of CO2. That goes in the first box. Next box, well, it's not asking for CO2 anymore, it's asking for water. So now we have to calculate how much water is produced. Notice how we're not using oxygen gas because that's not our limiting. If it's not our limiting, you don't touch it except when you want to use it. Use the values to figure out excess, because that's a reactant. But if you're going from reactant to product, you use your limiting reactant, which in this case is ethane. So this next one, you guys should, I would actually rather you pause the video, try doing the second one, trying to find how much water is produced, and then unpause the video and, verify. But pause it like now if you want to try it. And if you don't want to pause it, okay, let's do it then. So again, you start with the limiting reactant value of 0.257 grams of C2H6. I have a habit of putting stuff over 1, so hooray. Again, convert it to moles. So 1 mole of C2H6 equals the molar mass of ethane, which is 30.07 grams of C2H6. Now, again, we're jumping ship. So because we're jumping ship from ethane now to water, we have to use what associates the two together, which are the coefficients, the molar ratios. So we know that for every 2 moles of C2H6, we have 6 moles of water, of H2O. Let's write that again, but better. H2O. Perfect. So great, now we're at moles of H2O. Oh, I should probably start canceling out stuff, huh? Cancel, 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 cancel. Sorry, guys. Cancel out moles, cancel out moles. Okay, now we're at moles of water. Now we're asking for grams of water, so we have to convert from moles back to grams, which at this point you guys should be experts at. So, okay, use molar mass, and you know that 1 mole of water is equivalent to 18.02 grams of water. That's just the molar mass, right? Realize how it's not rocket science as to why moles goes on top for one of the fractions but goes on the bottom for the other. I'm canceling out units if you haven't figured this out yet, right? These cancel out. If you haven't figured that out yet, then come see one of the preceptors, because that's kind of important. Anyway, okay, great. So we go from moles of water to grams of water. We can cancel out the moles of water, and we're done. At this point, we just calculate and get a number, and that value is 0.462 grams of H2O. Done. That's it. Literally nothing else to it. So first you find limiting reactants, you find out which one's limiting, calculate the one that's in excess. When you calculate the one that's in excess, remember that you will first start calculating how much of the other reactant you're using. You have to use the initial amount of that second reactant minus how much you've used to get the excess. I've done this already, so if you need to figure out what I'm talking about, go back in the video. Biggest thing that people forget is when you're jumping ship from one compound, like right here, one compound to the other, right, from ethane to CO2 or from ethane to H2O, you have to use molar ratios. So I think this reaction, it was already balanced for you, but realize that this is not at all. You could be asked to balance your own equation. If you do that, make sure you're doing it correctly, or else you will get the wrong molar ratios and your answer will be very wrong. So just to verify, if you want the answers to this problem, I will write it out. So how much is reacted? Let's see. Okay, well, 0.257 is reacted. We have 0 left over. 0.957 grams is reacted. We have 0.493 grams in excess, and then we just did the math to this one. It's 0.752 grams of CO2 produced and 0.493 0.62 grams of water produced. So that's basically it. If you guys have any questions, email some of the preceptors. It is still spring break, so I don't guarantee any of the preceptors will respond. If you haven't figured out who is talking in your video, it's Jay. I will respond, as I have been doing to some of these students. So if you have any questions, please let me know. Watch the video a couple times, let it sink in before you ask the questions, because I've gone through this problem in as much detail as I would during a weekly review or even exam review. So realize that I wasn't rushing anything here. I was just writing very fast. But biggest things that you should worry about: finding limiting reactants, knowing how to find excess, knowing that you have to use molar ratios for everything, and at that point, just how to do math, how to cancel out units, blah, blah, blah. Again, if you have any questions, let me know. If you liked the video, awesome. I'd like to know if you did. If you didn't like the video, I'm sorry. I'm sorry. But okay, you guys, this should help you with the rest of the homework. So if it doesn't help you, I'm sorry. I don't know what else I don't know what else to do for you. What else? Okay, great. I'm done. You guys have a good rest of your spring break. Be safe. Don't hurt yourself, please. I do want to see all of you safe and sound in class on Monday. I will see you on Monday. You guys have a wonderful rest of your break.